Okay, here we are in video 2. We're on page 2 in the airplane problems section of our notes here. And I have to make a few quick comments here at the top. I know we've discussed the difference between bearings and direction. And if you're talking direction, it's the positive X, you go counterclockwise. If you're talking bearings, you start at north, straight up, and then you work your way clockwise. Within that, there's two ways to describe bearings. It's also known as an azimuth. So, whereas let's say we were talking like 135 degrees as a bearing, 135 degrees is down here in quadrant 4, looks like this. But what I wanted to point out is some of our problems may not use the azimuth, the 0 to 360 degrees. It might use bearings as true bearings, and that same 135 degree notation is going to look like south 45 degrees east. And so if you just were given south 45 east, what you have to understand is these problems, given a true bearing, it's always going to have a north or a south to begin with. You're either in the upper two quadrants or the lower two quadrants. And then east or west is, like in this example, instead of going straight south, I'm going to start straight south, straight down, and then I'm going to head to the east. So I'm going to go to the right, if you will, 45 degrees. So if you needed to understand that in terms of degrees, that would be 135 degrees. All within the world of bearings, nothing in direction, but it's just a note that I wanted to point out. If any of your problems you come across give you in a true bearing form, I wanted you to be able to understand that. So if you had, 135 equals south 35 degrees east, maybe, something like that to help you. But in general, you look at these, and that's what we're doing. Okay, so on to our first actual dumb pilot problem. Math involved, all the exciting stuff. So our plane is traveling due east. So let's get our picture going here. We've got, always start with your little radar and fill in the information as you get it. So the plane itself is traveling this. It is asking for the plane's resultant heading and airspeed. There is a quick, I need to change that. That should not say airspeed. That should say ground speed. I know it should say ground speed because up here it says the plane is traveling due east with an indicated speed. The indicated speed means like from inside the airplane. So again, you're the pilot looking at your speedometer, says 600 miles an hour. Which is extremely high. That's probably a little too high, but we're going to have to go with it. So the airspeed is like, that's you in the airplane. Ground speed is, again, like our first video, it's describing what does the radar look like after you've been affected by wind. So the dumb pilot means that we are being given the information from inside the cockpit, and we're not accounting for wind in terms of where is our destination. So if we know where we need to go and we're accounting for wind, we're a smart pilot. If, like in this problem, we are being given the information from the cockpit, we're a dumb pilot because we're very narrow-minded. We're looking just at our own instruments. So 600 miles an hour due east. So the plane, remember the plane is going to be our blue vector. That is pointed straight east, or as best as I can. That's P. Vector P is 600. Magnitude 600. The wind is blowing from the northeast at 30 miles an hour. So this is a great example. The wind is being blown from northeast. Well, northeast, they really do mean 45 degrees. There's north and there's east. So our vector is, first of all, red, is going to point this direction because it's from the northeast. It is heading to the southwest. So our arrow points southwest, and the magnitude of that is 30. Okay, so vector W, 30, with this southwest direction. Sorry, heading. Okay, so we do have the bearings, the speeds, the magnitudes of the plane and the wind. It says, what is the plane's resultant heading and ground speed? It's asking, just because I'm in the airplane, I'm looking at my compass. My compass says I'm heading east. I can't see the ground, but there's this 30-mile-an-hour wind pushing from the northeast at me. So I'm just going to kind of like with not an actual green, but like maybe like a fun little like mint green. We know that the plane isn't heading straight east. We know it's kind of heading like that, kind of, southeast. But we need to find exactly what that is. That's where the numbers come in here. So here's how we set it up. We are going to write out what vectors do we know. We know P. What happened? There we go. Let's try that again. So vector P, it's actually really nice. P is due east right here, which means in component form, all of that 600 is pointed in the X, and none of it is pointed in the Y direction. The other vector we know is our W vector, our wind vector. But we got to hold on for a second, because when we are doing vectors in this form, component form, we use direction. We do not use bearings. So again, it's not terrible in this case. We do have the magnitude of 30 degrees, and we have a reference angle 45, but we do need to find the overall direction from the positive x-axis. So the other thing I want to note too, by the way, we have a vector pointed down left. We have the two components, the x component of it and the y component of it. And when we know that the hypotenuse is 30 and the reference is 45, we can find the magnitude of the x and y components. So when you go back to the vector addition, like the very first part of this lesson, or this unit 4, we broke vectors into x and y components by saying the magnitude of the vector times cosine of the angle, comma, magnitude of the vector times sine of the angle. But we have to make sure that we use not 45, but again, the full angle here, which by the way is 225 because it's 180 plus 45. So in other words, the wind vector has the magnitude times cosine of your angle, so 225. And then the y component of the vector is 30 times sine of 225. See, and what that's going to do, if you did cosine of 45, you're still going to get the same magnitude value, but cosine 45 is going to be a positive number. Cosine of 225 is negative. So we do want to make sure that we account for that and we get negative answers. So in the end, we can get that simplified. I believe it's right around negative 21.2 for the x, and because it's a 45-degree angle, those legs are going to be the same, right? So reference angle 45. So 30 times the same cosine and sine values, you're going to get the same here. Now, what we don't know yet is the resultant, the actual. I do have a bit of a green line here, but that doesn't represent the exact value. What we're trying to do is find P plus W. Okay, that's the vector that represents where is the actual, like where's the plane going from a radar perspective. Because again, if I point myself like straight east in this case, the wind is also going to be pushing me. I don't see that because I'm up in the airplane. So I think I'm heading straight east, but the wind is pushing me kind of south and a little bit a headwind. So I'm not actually going to end up straight east of where I end. I'm not going to end in Dubuque. I'm going to end somewhere maybe down by Davenport. Okay. So what we want to know is, what is that actual resulting vector, p plus w? Well, we don't have the math available to it. Like we weren't given that information. We need to find it. Well, if you look at what the root of this vector is, it's p plus w. Here's p, here's w. So all we need to do is take the x components of p and w and combine them. Same thing with the y components. And in that case, 600 minus 21.2, we get 578.8 roughly. 0 plus negative 21 gets us to negative 21. So we have the final resulting vector after the wind is taken into account. Well, that's 578 means we're not quite as long of a vector in the x direction as the p, but we're also down 21. So we're going to be somewhere down there like that, and that's our p plus w. So we're at least halfway there. We know what the vector looks like, but the question's asking for the resultant heading and ground speed. Well, the ground speed is the magnitude of that arrow. So we have the x, we have the y, we need the hypotenuse of this triangle. So we have this, we have 578, we go down 21, so we know, we want to know the hypotenuse. This is 578, and this is 21. So using Pythagorean theorem, you find that the magnitude, so I'm going to call that the magnitude, p plus w, is 579. Based on roundings, it does turn out that just taking the square root of such a large number plus another number and square rooting, it came out to just rounding up to 579 miles per hour. So there you have the resulting ground speed. So even though my speedometer says 600 in my airplane, on the ground, it would look like my shadow is only moving 579 miles an hour. Now, what direction is that? Well, again, I say we use this triangle. We find the angle here. So tangent, right? So we use tangent alpha. What that gets us is an angle of 2.1 degrees. So if alpha is 2.1 degrees from the, our easterly direction, 2.1 degrees from a bearing, right? Our heading, we have to call that a heading of not 2 degrees, not 2.1, but rather from north, I go all the way around 90 degrees, and then just a little bit more. I exaggerated, I apologize. That arrow should be much closer to the horizontal, but 2 degrees. So a heading of 92.1 degrees. So there you go. You guys did your first pilot problem. I don't think it was that difficult. I don't imagine you did either, but I will continue with another video. I will not be doing the example of a dumb pilot using law of cosines, but I will be doing more problems. I'll probably skip to the next one on the next page there. But thank you for bearing with me. Please, again, use this as much as you can or as much as you would like. And I will see you guys in class tomorrow, and we will continue working on more of these. Or you can watch the next video and try and get a smart pilot problem done.